Hey everyone, welcome to The Art of Code. My name is Martijn, and one of the first effects that I ever did back in the day when I first started programming was a starfield effect. And I decided to make a 2020 version of that, so that's what you see behind me here. And in this video, I'll explain how to make this from scratch. So if that interests you, then stick around. So the first thing I'm going to do is I'm going to click New. Get rid of this thing. And let's see here. Let's start with cleaning this up a little bit. If you're new to SHaderToy, then I recommend this video. But if not, then let's just do what we normally do. So I'm going to make it that the UV coordinates have their origin in the middle and that their aspect ratio corrected. And then I'm going to make a black screen. So I'm going to go over here. I'm just going to go vec3 that. And I'm going to do the same thing. Or not the same thing, I'm just going to do that. So that will give me a black screen. And then let's start by drawing one star. And in order to draw a star, we need the distance from every pixel to the center. So for that, I'm just going to use a float d for distance, and I'm going to take the length of the UV coordinate. And because the UV coordinate has its origin in the middle, the length of UV just gives me the distance to the center. And if you followed any of my other videos, then you might think, well, we could just use a smooth step to draw a circle. So let's just do that real quick. So I could do, for instance, this, and that will just cut me out a circle, and then I have to add it to my color, and there is a circle, right? And I could change the size of that or whatever have you. But the thing is, if you want any kind of effect that is simulating a light, then this is not the best way, because the fall off here, so it goes from fully bright to fully black, the fall off is not the same as what a light would have. One major thing here is that it actually goes to 0 over here, and then it's just 0 everywhere. Whereas you get a much nicer fall off if it goes close to 0, but it's an asymptote, so it never actually gets to 0. So wherever you are on the screen, there's always some contribution to the light. And so what is a lot nicer is if we do something like this, if we say 1 divided by the distance. And that will give me a widescreen because I need to make that a little bit smaller. So if I do, let's say, 0.01 divided by d, then you get something like that. And that looks a lot nicer. Let me just make it a bit bigger. It looks a lot more like a light. So let's use that instead. I'm going to make it a little bit smaller, something like that. We can get rid of this. And then the next thing I want to do is I want to make some rays on that, or a lens flare on that, like two rays that come in across, like this. And for that, let's see what we can do. Let me just repurpose this M here for 1 second. Let's just use it to look at the UV coordinate. So the UV coordinate is 0 in the middle, and then it goes to 0.5, and it comes from 0.5 or negative 0.5 over here. If I take the absolute value of that, then I will just fold this part over. And let's zoom out a little bit. So to zoom out, I can just multiply my UVs times some larger number over here. Because right now I'm looking at, like, I see minus 0.5, 0, and then 0.5. But if I multiply this, then it would go from minus 1.5 to plus 1.5. And that's why this would zoom out. Okay, so that's for X. I can do the same thing for Y, and then it will just give me a horizontal line. And if I multiply these two together, uv.x times uv.y, I get something like this, which you could use to make that star shape. So let's play around with this a little bit. Well, first of all, obviously I don't want that star to be dark and then the rest to be white. I want it to be the opposite of that. So for that, I could just do 1 minus this thing, and then it will turn that around. And now let's try to make it a bit smaller. So I can multiply this by some larger number to make it smaller. And Let's see here. Let's call this rays just for now. So float rays equals that. And then here I'm adding my star itself. And then here I can add the rays as well. So plus rays. And so right now the rays are obviously too large for this. So let me just make it smaller. So I can play around with these numbers until I find something that works. Okay, so apparently this needs to be quite large. Okay, there's another effect at play here, which is that this rays can get smaller than 0 right now, and that's what's deleting the rest of my star, so I can't see it. This can get smaller than 0 because this can get arbitrarily large, right? So so we want to make sure that it doesn't get negative, so that we don't subtract in the black areas. So for that, I could just do max 0 on this. And so now, if I multiply this by some larger number, then, okay, well, I have to multiply by a very large number for me to see the actual star. So let me make the star a bit bigger. Okay, so there it's coming. Okay, so something like that. And let's see here what else we can do. I guess, well, if we do this, then it's going to be smaller. Okay. Let me see here. Okay, well, I guess that's okay. That looks good. So let's just stick with this. And I'm going to add a second set of lines here at a 45-degree angle. And because I'm going to rotate something, I'm just going to add a rotation function here. So rotation function, I've done it before in other videos. It just takes as an input an angle A. And then for a 2D rotation, it's quite simple. You keep track of the sine of that angle. So sine of A. And then you keep track of the cosine of that angle. Cosine of A. And then we're going to return a matrix that is the cosine minus the sine, and then the sine and the cosine. And that gives me a 2D rotation matrix that I can use to rotate things around. So let's go over here. No, let's go over here. And let's rotate the UV coordinates. So I'm going to rotate it. And this is in radians. So an entire 360 degrees is 2 pi radians. So 180 degrees is pi radians. So pi radians, pi would be that. And then, so that is 180 degrees. So if I divide that by 2, then I would have 90 degrees. And if I divide 2 by 2 again, so by 4 in total, then I get 45 degrees. So this would be a 45-degree rotation. And then I can just use this whole thing again. So I can go over here, stick that over there, and let's see. So that adds me the second one. And I don't know why the first one doesn't go all the way up, the rotated one does, but we're going to get rid of that later anyway, so don't worry too much about it. I'm just going to make it that the second one is not as bright as the first one. Something like that. If you have more time, you can probably compact this a lot, but I'm not going to deal with that now. I leave that up to you. Because we have to move on. So yeah, I think that looks okay. Again, we're gonna fade it after. Don't worry about it. So let's make a few of these. Actually, no. Before I do that, let me just take this thing and put that in its own function, in a star function. So I'm just gonna cut that out. I'm gonna go over here, float star, which takes as an input a UV coordinate, and also I want to be able to attenuate that flare. So I'm going to add a flare parameter here that if it's 0, then we don't have to cross on the star. And if it's 1, we do. So I'm just going to copy that, and then I'm going to have to see here. So we don't have a col inside of here, so I'm just going to get rid of that over there. And then over here, I'm just going to say m plus equals rays and m plus equals rays. And I'm just going to return my value m. And then over here I can test if that works. I could just say plus equals star of UV, and then with the flare on it like that. So I compiled it, nothing changed, so that tells me it worked. But now I can also turn that flare off. I could just say, okay, well, I have to obviously add it. So here is my flare. I have to go over here and I have to say raise times flare, and over here also raise times flare. Okay, so now I have no flare, and now I have a flare on there. And yeah, as I said before, this can be refactored in order to make it less instructions, but I'm just going to leave it like this for now. Okay, so now let's make a bunch of these. So for that, I am going to go over here. I'm going to say vec2 GV for grid UV, and I'm going to make a bunch of boxes first. So and I'm going to say it's the fractional component of my UV. So let me just visualize that so we could see what we're looking at. Call.rg equals GV. Okay, so that gives me a bunch of boxes because fract, so my UV goes from -3 to 3, and fract just makes it that it just returns the fractional component each time. And so that's how I get this repetition here. And I can get as many boxes as I want. If I just multiply this by a larger number, I get more boxes. So now for each box, I want the origin, because right now the origin is in the lower left corner. I want the origin in the middle. So I'm just going to subtract 0.5 from that. So right now, this goes from 0 to 1, right? And also over here from 0 to 1. And so if I subtract 0.5 from it, then I will just remap the middle point to be the origin. So then you get that. And now if we use over here, if instead of UV we use GV, then we get a bunch of stars for the price of 1, which is pretty cool. Let me also visualize the edges of each box so we can see better what we're doing. So I'm going to say if gv.x is larger than 0.48 or gv.y is larger than 0.48, then make it, let's say, red, so that we have a red outline on everything so we can see the boxes. Right, so now what I want is for each box, I want that star in a different position. And if we want something different for each box, then we first need a value that identifies each box. And so for that, I'm going to make an ID. And the ID is just going to be the floor of my UV. Floor of the UV. So again, my UV coordinate goes, let's say, -3 over here, and then it's -2, and it goes, and it goes to 0, and then it goes all the way to 3 over there. And what floor does is it just rounds off or it just truncates the number so that we only have the integer component. So I've said it many times before, fract and floor are two sides of the same coin, basically. So floor keeps the integer component of a number, and fract keeps the fractional component of a number. So if you add these two together, then you have the original number that you started with. So we can also visualize this. So if I go over here and I say col.rg plus equals ID, now I can see that every box has a different color, although over here it's saturated, so you can't really see it. But if I multiply this by a smaller number, maybe a bit larger than this, well, something like that, you can see that every box has a different color. But for every pixel in the box, the colors are the same. If you don't take, just ignore the star for now. So we can use that to position these stars. All right, so in order to position these stars, we want these stars to be randomly positioned. So I have to make a random number generator. So for that, I'm going to go over here. And again, we've done this many times before. I'm going to make a hash function that takes 2 numbers as an input, and it returns 1 number as an output. So as an input, it's going to take a vector 2, call it p. And then I'm just going to do this. I'm going to say multiply my vector p by some other vector 2 over here that is larger or on the larger side. So now my p is a lot larger than it was before, and now I take the fractional component of that. So now that p is going to have an x and a y component that are somewhere between 0 and 1. And now I'm going to add to that the dot product of p and p plus some other number. And this is just some mathematical screwing around to twist the number in such a way that that the end result looks random, even though it isn't really random. So I'm going to return the fractional component of p dot x times p dot y. Yeah, and that just gives me a pseudo-random number, and so we can look at that. So if I go over here and I say col plus equals hash 21 of the UV coordinate, then I get a bunch of snow, television snow, because for every pixel that UV coordinate is different. But if I take ID, then you'll see that every box now has a different value, but inside of the box it has the same value. So that's exactly what we want. So now we can use that in order to position the star. All right, so now how do I reposition the star? Well, this star function makes a star at the origin, makes a star around 0, right? And so if I want to move the star, if I want it to appear somewhere else, then what I have to do is I have to remap the origin to somewhere else. And so in order to do that, I could just subtract here something from that, right? So obviously if I subtract 0, 0, nothing's going to happen. But if I wanted to move it up, for instance, I could just subtract a little bit from that position, and now I can move all of them up or down or left or right. But I don't want to move them by a fixed amount. I want to move them by a different amount for each star. So let me first make that random value for each star. So that's my hash 21 of my ID. All right, so now that's a random value. So that's random, but between 0 and 1. And so now I could use that, for instance, in my x component. So now I have stars that are randomly moved from left to right. It's just that because this is between 0 and 1, and my box goes from minus 0.5 to 0.5, a lot of stars actually move completely outside of the box. We have to subtract 0.5 from this in order to get them all inside of the box still. And now I need to do the same thing for y, but if I use the n for y as well, then I can only move stars on a diagonal, which is obviously not what we want. We want another random value for the y. And so I could use this hash 21 again with a different input, but like another way of doing it is I could just do something like this. Well, actually here, I could, so my number n is between 0 and 1. I wrote between 0 and 1. It's between 0 and 1. Yeah, so if this is between 0 and 1, and if I multiply this by, let's say, 10, now it's between 0 and 10. And now if I take the fractional component of that, now it's again between 0 and 1, but now it depends on where the original n was, right? Because if the original n was, let's say, 0.19, then if I multiply it by 10, then I have 1.9, and if I take the fractional component of that, I get 0.9. So I basically I'm extracting another random number that is just part of the original number, but it's past a certain decimal place. And you don't have to multiply this by 10. That was just for illustration purposes. You could multiply this by any number and get another pseudo-random number out of it. And then over here I would also have to do minus 0.5 in order to get that random. All right, so now I have random up, down, left, right. One thing here is if I multiply, or if I subtract 0.5 from both the x and the y, then I could just take that out and put that outside here. So minus 0.5 and what did I do wrong here? Oh yeah, okay. I would have to put brackets around this for that to be correct, right? So if I don't want those brackets, then I have to actually add 0.5 to get the same effect. All right, so now we have a bunch of stars that are all moved around. Now there is obviously a very obvious problem with this, which is that around the boundaries it doesn't look so nice, because every box should really take into account like a potential glow or a potential part of a star or a part of a flare from a neighboring box, right? So let's do that. So what we need to make is we need to, for each box, let's say for this box, we need to add contributions from this star, from all of these neighboring stars. We need to add the contributions to this box. And we need to do that for every box so that there are no boundaries, no visible boundaries. So I'm going to iterate through the local neighborhood of each box. Okay, so each box has a local 3x3 neighborhood, right? And so for that, I'm going to go over here. I'm going to say for y equals -1, and then y is smaller than or equals 1, and then y plus plus. So this y is going to start at -1, and then the second time around it's going to be 0, and the third time it's going to be 1. And I'm going to do the same thing for x. So I'm going to go over here. I'm going to say x, and x, and x. All right, and then I'm going to stick that in there, and I'm going to stick this in there. And I'm going to close my loops. Okay, so now I have a loop that goes through the that loops 9 times, and now for like each time I get through this loop, I have to add the contribution from a neighboring star, right? And for that, I have to get the ID for the neighboring star so that I can get a random value for the neighboring star. And so for that, I have to make an offset. So I'm going to do vec2 offset. That is just the x and the y of my loops. All right. So yeah, it's going to start at -1 and it's going to end at 1. And in the middle, for the box that we're currently in, this offset is going to be 0. So if I add that over here, the offset, then that's gonna add the contribution from all of the neighbors. And then I just have to make sure, because this GV here is if we want the distance to a neighboring star that's in a different box, then we have to add this offset here as well, because otherwise, because this just calculates the distance with respect to the box that we're looking at. So for that, I have to, over here, subtract the offset, so offset minus. Okay, and that should add all the contributions from all neighboring stars, but I have to obviously say int over here, otherwise it's not going to work. And then over here also I have to say int. And does that look correct? Well, yeah, I guess it is. Okay. It looks a bit weird to me. Let me see here. No, that's obviously still not good. Why is that not good? Look at him struggling with this. Maybe we should give him some time. I figure that this is a good spot to stop part 1 of this video. If you're a patron, you can go to Patreon right now and get part 2 right away. If not, you're gonna have to wait a week, unless you're watching this 2 weeks from now, or 3 weeks, or a year from now, and then you can get it right away. Oh, okay, yeah. Well, we obviously still need to cut out. Falloff goes on forever, right? So it goes on past the first box, or even past the second box, or past the 10th box.